For years, there's been a quiet buzz in the scientific world, almost like a whispered rumor, that the James Webb Space Telescope would just be powerful enough to detect something incredible, the signs of life on distant exoplanets. We're talking about the ability to actually read the atmospheres of these far-off worlds. And maybe, just maybe, pick up a biosignature. That's a chemical clue that something alive could be out there. Well, hold on to your seats, because the media is heating up with a story that could be the real deal. There's growing evidence that JWST may have actually found one, and if this discovery is confirmed, it would completely change the way we think about life in the universe. I'm not exaggerating, this could be huge. Wait, did I just say alien life? Yep, you heard that right. But before we dive into all the cosmic details, do me a quick favor, hit that like button. And if you want to stay up to speed on the latest space discoveries, go ahead and subscribe. Trust me, you won't want to miss what's coming next. K2-18b. Remember that name, because it might just go down in history. This distant exoplanet is about 2.5 times the size of Earth and sits a staggering 124 light-years away. That's over 700 trillion miles from us, way beyond the reach of any human spacecraft, at least for now. But here's where it gets wild. The James Webb Space Telescope is so incredibly powerful. It can analyze the atmosphere of this planet from all the way over here just by studying the starlight that passes through it. That tiny red star K2-18b orbits. It acts like a cosmic flashlight, helping JWST sniff out chemical clues in the air of this alien world. And here's the kicker. This could be the first real sign of alien life we've ever detected. Not science fiction, real science. Let's break it down. K2-18b is a sub-Neptune, about 2.6 times the size of Earth, and nearly 9 times as massive. It orbits in the Goldilocks zone of its star, not too hot, not too cold, where liquid water could exist. And get this, it gets about the same amount of energy from its red dwarf star as Earth does from our Sun. A full orbit takes just 33 days. This is no cosmic neighbor, it's far enough away that there's zero chance life there came from here, or vice versa. If life did spark on K2-18b, it happened independently. That means we might be looking at proof of a second genesis, another origin of life, totally separate from Earth's. Oh, and a fun fact, K2-18b was discovered by the Kepler Space Telescope, just like the mysterious Tabby's star, another contender in the search for alien life. And trust me, we're just scratching the surface. There's so much more to unpack about this strange and fascinating world. Stick around. Now here's something that'll really make you think. The star system that K2-18b calls home is around 2.4 billion years old. That's pretty young in cosmic terms, but here's where it gets intriguing. At that same age, Earth already had photosynthesis going. Life here had started pumping out oxygen into the atmosphere. But on K2-18b, no signs of oxygen have been detected, at least not yet. That might mean there's no photosynthesis happening there. Or, if there is life, it could be using a totally different method to survive. Alien biology might not play by our rules. And this isn't just a random rock floating in space. K2-18b first caught scientists' attention back in 2019, when water vapor was discovered in its atmosphere. That was a game changer, because where there's water vapor, there could be actual liquid water. It raised the possibility that this world might be an ocean planet, maybe even covered in a global sea. The big question now is, what does all this really mean? We're still connecting the dots, but one thing's for sure, K2-18b just keeps getting more fascinating the more we learn. In 2023, researchers using the James Webb Space Telescope discovered that K2-18b's atmosphere contains both carbon dioxide and methane, two gases often linked to life. Now, to be clear, these gases can come from non-living sources too, especially carbon dioxide, but finding them together, that definitely raises eyebrows. Since then, scientists have been trying to figure out what this mysterious planet is actually like. Is it a small gas giant, kind of like a mini Neptune or Uranus? Or is it something way cooler, like an ocean world? If it's the latter, K2-18b might be what's known as a Hyacinth world, a theoretical type of planet that has a deep liquid water ocean beneath a thick hydrogen-rich atmosphere. Picture a vast, alien sea, no land in sight, and any life there, probably swimming, not walking. Kepler spotted a few potential Hyacinth worlds, but none have gotten the attention that K2-18b is getting right now, and for good reason. Because here's the jaw-dropper. In 2023, JWST also picked up a signal faint, but they're of a chemical called dimethyl sulfide DMS, and as far as we know, on Earth at least, this gas is only produced by life, specifically by marine organisms. But hold on, before we start sending welcome messages to the stars, the detection was super faint, and a lot of scientists were skeptical. Could it have just been noise in the data? To find out, the team at the University of Cambridge went back for another look using a different instrument on JWST. And guess what? The second round of data pushed the signal to what scientists call 3 sigma confidence. That's not a slam dunk, but it's solid enough to say this might actually be real. If confirmed, it would be absolutely historic. This is a big deal because right now, there's only a 0.3% chance that what JWST picked up was just a random fluke. That's already pretty convincing. The signal could be coming from one of two gases, or possibly both: dimethyl sulfide DMS and dimethyl disulfide DMDS. And here's the wild part: both are believed to be produced only by biological processes. But we're not there yet. To really lock this in, scientists are aiming for what's called a 5 sigma detection. That's the gold standard. At 5 sigma, the odds of this being a fluke drop to just 0.00006%, basically 1 in 1.7 million. That's the level of certainty you need to seriously claim a potential biosignature. The good news: the team believes they can get there with more time on the James Webb Space Telescope. And with a 3 sigma detection already in hand, they're in a strong position to make that happen. Now here's something that adds weight to all of this. The original 2023 reading was taken using JWST's NIRISS and NIRSpec instruments, but the most recent detection that came from MIRI, a totally different instrument. That means this is an independent detection, which makes the case even stronger. Still, scientists are being careful. We're not waving the alien life flag just yet, and for good reason. If these results keep piling up, the first thing researchers will ask is, could there be another explanation? Is there some strange, unknown chemistry happening on K2-18b that could be producing these gases in large amounts without life? And yeah, here's the part that really has scientists scratching their heads. The concentrations of these gases on K2-18b, they're about 20 times higher than anything we see on Earth. So, could this be biology? Or are we about to discover a whole new kind of chemistry playing out on a world 124 light-years away? Some earlier theoretical studies actually predicted that if we ever found life on a Hyacinth world, we'd see exactly what JWST is now picking up: high levels of these 2 gases. So far, everything lines up perfectly with the idea of a planet like K2-18b hosting microbial life in an alien ocean. Now, let me be clear, we still need to be cautious. This isn't confirmed life, we're not there yet. But make no mistake, this is by far the strongest candidate we've ever had for an actual biosphere beyond Earth. And if the data holds up under further scrutiny, it's going to be hard. Looking ahead, the future of exoplanet research is seriously exciting. One day, we might actually be able to directly image K2-18b and, if we're lucky, spot that elusive vegetative red edge that could signal plant-like life. But of course, with new possibilities come new challenges. Here's one that astrobiologists have been wrestling with. Planets more than twice the mass of Earth, like K2-18b, might actually be less likely to support life. Why? Gravity. Once a planet gets that big, its gravity can become absolutely crushing. Now, that might not be a deal breaker for a hardy microbes or extreme life forms life, that thrives under pressure, literally. But for anything more complex, it could be a serious problem. The planet's surface might have very calm, almost eerily still oceans due to that intense gravity, though tidal forces from other nearby planets in the system could still stir things up below the surface. Bottom line, this is a seriously alien world. If you could somehow stand on it, unlikely, but let's imagine you'd feel that crushing gravity pulling you down hard, and if you could take a breath again, not recommended, you'd notice something weird. It would smell like cooked cabbage. Yeah, really. That's thanks to dimethyl sulfide, one of the gases possibly detected there. Funny enough, we actually use that chemical in small amounts as a flavor additive. It's what gives veggies like asparagus and Brussels sprouts their savory kick. So ironically, alien life, if it exists there, might taste kind of good, but don't get any ideas. In the concentrations being talked about on K2-18b, dimethyl sulfide would be toxic to humans. It's present in our bodies in tiny amounts, but at high levels, it can cause all kinds of problems, including a type of blood-borne halitosis and other serious health issues. So, yeah, delicious or deadly? Maybe both. One thing's for sure, this planet keeps getting stranger and more fascinating by the day. Here's something that really ramps up the mystery. Whatever is producing these gases, especially dimethyl sulfide, it's doing so on a massive scale. Why? Because this particular gas doesn't stick around for long in a planet's atmosphere. It breaks down quickly. So for JWST to detect it at all, something has to be constantly pumping it out right now, and in serious quantities. That kind of large-scale, ongoing replenishment, life can totally do that. We've seen it here on Earth. But some weird, unknown chemical reaction doing the same thing, that's a much harder sell. It's not impossible, just a lot less likely. Now, let's talk about the bigger picture, because the implications of this are huge. K2-18b orbits a red dwarf star, and that matters a lot. If this really is evidence of a living biosphere, it would shake up one of the biggest debates in astrobiology. Can red dwarf systems actually support life? For years, scientists have gone back and forth on this. The main argument against it: red dwarfs are kind of wild in their youth. They're known as flare stars, blasting out intense radiation that could rip the atmospheres right off of nearby planets, which, in red dwarf systems, is exactly where the habitable zone tends to be, really close in. And so far, research with JWST looking at the TRAPPIST-1 system, another red dwarf with Earth-sized planets, has seemed to support that idea. Those planets may have lost their atmospheres early on, but if K2-18b still has an atmosphere and is showing signs of active chemistry that just might point to life, that's a game changer. It could mean that some red dwarf planets can hold on to their atmospheres after all, and maybe even nurture life. We're looking at something that could rewrite our understanding of where life might exist in the universe. The two planets closest to the star, no atmospheres, but K2-18b, it's got one, and that's a big deal. Some research suggests that the way red dwarfs work might actually be a blessing for life. Unlike other stars, red dwarfs don't flare up at their equators, meaning their flares don't hit nearby planets. That makes those planets much more stable and, potentially, perfect for life. Now, if this latest detection turns out to be valid, and life is the simplest explanation, it's going to completely shift how we think about the universe. Why? Because red dwarfs make up 73% of all stars in the Milky Way, and the majority of them are thought to have planets in their habitable zones where life could exist. So, if we're seeing signs of life just 124 light-years away, and red dwarfs are actually viable for life, that suggests the universe is probably teeming with microbial life, at least. But let's not get ahead of ourselves. This doesn't mean intelligent alien civilizations are just around the corner. The big takeaway here is that, if this pans out, Earth's not alone. But and here's the twist, there's a bittersweet side to all of this. K2-18b's high gravity can actually be a deal breaker for any kind of advanced civilization. Why? Well, high gravity worlds are tough to escape from. Chemical rockets? Not likely. The planet would be trapped. And it's hard to imagine any kind of space exploration coming from a world like this. No satellites, no space stations, nothing that would push a civilization's development into the stars. But here's the even bigger issue. If K2-18b is mostly ocean, like scientists suspect, any complex life might be locked away deep underwater. That means no land-based civilizations, no sprawling cities, just an ocean-bound biosphere. It's a fascinating idea, but one that may not lead to the kind of societies we'd recognize. So while K2-18b could be a big step in proving life exists elsewhere, the chance of intelligent, spacefaring aliens there, pretty slim. But still, the idea that microbial life could be thriving on another planet, 124 light-years away, is mind-blowing. On Earth, most ocean life exists near the surface, especially phytoplankton, which rely on sunlight. Now, imagine if K2-18b has life, but it's stuck deep in its ocean. Any intelligent life there would be trapped, with no way to mine metals or create technology. That's a big deal because it could help solve one of the universe's biggest mysteries, the Fermi paradox. What's the paradox? It's the question. If the universe is so vast, why haven't we encountered intelligent aliens? The answer might be simpler than we think. Intelligent life that can leave its planet may just be extremely rare. That's a sobering thought, but it paints a picture of a universe where most intelligent species are stuck, unable to reach the stars. And here's where it gets even more intriguing. If we ever manage to travel to other exoplanets and encounter these locked-in intelligences, we might find ourselves in the role of uplifters. Essentially, we could become the ones to help them, offering a chance to escape their planets and start new lives in the galaxy. But that's a massive if. If we ever figure out how to get them off their planets, we might just be the rescuers of the Milky Way. Now, let's flip to another bizarre possibility. If K2-18b is an ocean world, it could mean that abiogenesis, the process that sparks life, can actually happen around deep ocean hydrothermal vents. But here's the kicker. Earth-based research had pointed to volcanic hot springs on land as the most likely birthplace of life. If this new evidence holds, it could mean that life has two ways to get started, depending on the environment. That strengthens the case for microbial life being everywhere, potentially in places we've never imagined. But the plot thickens. Some researchers have proposed alternative, lifeless explanations for the strange data coming from K2-18b. There's a serious debate in the scientific community about whether dimethyl sulfide (DMS) and dimethyl disulfide (DMDS) are really there, or if the planet's composition is being misinterpreted. One of the key arguments for the planet having an ocean is the absence of ammonia in its atmosphere. The idea is that ammonia would be absorbed by a massive body of water beneath the surface. But, and this is a big but, there's also the possibility that K2-18b could have a molten rock ocean instead. That would mean no life as we know it could survive there. So, here's the big picture. We might be on the verge of confirming the very first detection of alien life. How wild is that? We're so close, it's almost within reach. But even if the evidence doesn't hold up, we'll still walk away with groundbreaking insights about how gases like this form and end up in the atmospheres of distant exoplanets. If this does turn out to be life, though, well, that's a game changer. It'll likely lead to Nobel Prizes, and it'll further cement the James Webb Space Telescope as a true legend in space exploration. But here's the twist: what if K2-18b isn't the oceanic world we think it might be? What if it's actually just a sub-Neptune gas giant? That would make these gas detections even stranger. Why? Because it would narrow down the non-biological explanations dramatically. Essentially, it could rule out things like geological processes, leaving us with one mind-bending possibility. Maybe this planet's gases are a technosignature, not just a biosignature. What if K2-18b is giving us clues about advanced alien technology? So, what do you think about these recent discoveries? Are we on the brink of finding life beyond Earth? Or is there something else at play here? Drop your thoughts in the comments below. Wait to hear your take on this. Thanks for watching. and I'll catch you in the next video.